Okay, class, again, good afternoon. So, this is the final presentation in hydroelectric power plant class. Okay? So, I will give you another example in this uh, presentation. Okay? So, let us now consider this example. An impulse turbine which has a diameter of 60 inches, speed of 350 RPM, bucket angle of 160 degrees, coefficient of velocity of 0.98, relative speed of 0.45, and then the generator efficiency of 90%, factor K of 9.9, and a jet diameter from nozzle of 6 inches. Compute, okay, power input, power output, and then total electrical energy generated if it operates at 8,760 hours. Okay? So let us now consider the solution. Power input is equals to the unit weight multiplied by Q and effective head. And knowing that the peripheral coefficient is equals to velocity of the runner divided by the velocity of the jet, or that is pi dn over square root of 2gh. Okay, so substituting values now, we can easily determine the effective head of the this uh, power plant. Okay, so the effective head now is 643.817 feet. Okay, so actual velocity now is equals to the velocity coefficient multiplied by square root of 2gh, so that is now 199.545 549 rather feet per second, or almost 200 feet per second. So getting now the discharge, that is Q equals to area, cross-sectional area of the 5 of the penstock rather, multiplied by its velocity. So pi d square over 4, area is equals to 0.19635 square feet. Or substituting now the value of the velocity and the area, so the discharge now is 39.1814 cubic feet per second. So the power input now is equals to 39, okay, so Q multiplied by the density of water, which is 62.4 pound per cubic feet, and then multiplied by the value of effective head, so divided by 550, so to make it horsepower. So the power input now is 2,862 horsepower. Okay, so for the power output, so power output is equals to 2 pi Tn. Okay, so over 60. So tangential force acting on the bucket. Okay, so we have here, so this is quite difficult class. Okay, so the tangential force now is equals to W over G multiplied by Q multiplied by the factor 1 minus cosine beta over 1 plus K multiplied by the velocity minus the velocity of the runner. Okay, so or simply peripheral coefficient equals to U over V. So getting now the value of the velocity of the runner. Okay, so that is the peripheral coefficient multiplied by the velocity. Substituting values, the value obtained is 91.63 feet per seconds. Okay. Okay. So substituting values now, the value of the tangential force acting is 12,246.8 pounds. Okay, so getting now the torque. So torque equals to F multiplied by R. Since the diameter of the runner is 30, so the torque now generated is 30,617 foot-pounds. Okay, so for the power output now, 2 pi Tn over 33,000 to make it horsepower. So that is equals to 2,040 horsepower. For the electric energy generated, so that is 20,040 multiplied by 9 multiplied by 0.746, changing this to kilowatts. So multiplied by the 8,760 hours per year, the energy generated is 11,998,187 kilowatt hours. Okay? So thank you very much, class. So I think it is now very sufficient for you. The given examples, I think it is now very clear for you. Okay? Thank you very much.